Good morning, everyone, and welcome to a presentation of the paper Contemporary Issues and Challenges to Enable Cyber Situational Awareness for Network Security. This is a systematization of knowledge paper. My name is Martin Husak. I'm with Masaryk University. This is a joint work with Tomáš Jirsík, also from Masaryk University, and Professor Jay Yang from Rochester Institute of Technology. The motivation for our work is the investigation of the current status and challenges of research on cyber situational awareness. Goals of our work were to discuss the definitions of situational awareness and cyber situational awareness, reviewing literature, identifying influential researchers and fundamental works, revising an existing taxonomy of CSA, and identifying the challenges for future work. First, let's talk about definitions. Situational awareness as a generic concept is present in everyday life. It was first recognized during World War I. It was studied in military and aviation from 1980s. And from the time, we have three major definitions, such as perceptual cycle, interactive subsystem, or 3D-level model. Situational awareness is everywhere in any domain, and cyber situational awareness is an application of situational awareness into the cyber domain. The 3D-level model is a definition of situational awareness that suits the CSA the most. It consists of three levels. First, there's a perception. On this level, we perceive the data and the elements of the environment. Once we achieve the perception, we may proceed to the second level, which is the comprehension of the meaning and significance of the situation. When we can understand the situation, we achieve the second level and may proceed to the third level, the final level of situational awareness, that is projection of future states and events. And on this level, we are able to project what is likely to happen in the near future. When discussing cyber situational awareness, we have to keep in mind that there are several specifics of CSA, namely the cyber environment, because the cyber environment has no borders, is scale-free, and basically everything can be everywhere. Other problem is the perception, because we can no longer rely on physical observations, and we have to perceive the environment using only sensors, such as network monitoring, system logs, and so on. The other problem related to this is the performance, because the high speed of events makes it difficult to analyze large volumes of data. And also, we have to face unbalanced needs of resources, because the defender needs many more resources and volume of data to detect an attack than the attacker needs to perform the attack. Finally, in contrary to traditional military doctrine, the attacker takes the advantage instead of the defender, because attacker can choose time, way of how to attack, while the defender has to always prepare for everything. What is also interesting in CSA is that we have entities, physical, immaterial, and human entities. Physical and human entities can be further characterized by roles, but most important are the immaterial entities, such as programs and services in computer networks. When, especially in recent years, with the emergence of cloud computing, there is very loosened connection between the services and programs and the devices, and the services and programs are no longer tied to a single device. Let's move on to the review of research on CSA. we performed a brief review of literature, which shows the number of publications on CSA is still rising, and it's still an important field of study. Namely, an IEEE database, the number of publications, namely research papers, is rising from year to year, as we show on this 10-year graph. What we identified in our brief literature review was that there are several fundamental works. For example, free collections in books, as presented here. The first two present a very good introduction to the topic, while the third one contains updates on the topic from the two previous books. If we are interested in systematic review, we may recommend the survey by Frankel Brynjolfsson from 2014. Also, while going through the research works, we identified several research groups that contributed most to the topic or made the biggest impact. For example, we have 3 research groups in US that contribute a lot of very highly impactful research works, such as a research group at George Mason University, US Army Research Lab, or Rochester Institute of Technology. Also, we have research groups in Europe, in Sweden, Austria, and Czech Republic that are working on these topics. We also surveyed research data that are used in the publications. And here is a list of data sets. The outcomes are that either we can use DARPA datasets that were very popular, but are no longer recommended because they're obsolete and contain flaws that make them unusable. We would recommend the UNB datasets, which is a large collection by University of New Brunswick, or if you are interested in particular topics, then some of the following datasets. What is interesting is the MMTBM dataset, that's on the last line, which is not very well known, but contains network topology and background noise, which is very important for CSA research because we can process data from a network with artificial background traffic, on top of which there is something happening which we may either detect or process. Finally, during the literature review, we found many references and mentions of cyber situational awareness in national policies, which shows that CSA is no longer just a research problem, but is an impactful term that appears in national cybersecurity policies and strategies, such as in these examples from Australia, USA, Germany, and UK. And it shows that situational awareness is a crucial term, crucial area of research that managed to get from research to real world. In the next part of our work, we updated a taxonomy and enumerated components and tools for CSA. For this purpose, we used the taxonomy proposed by Antti Avesti and his colleagues in 2017, which is actually a good taxonomy, a good enumeration of tools for operational and strategic data gathering and analysis and visualization of the data. But we found that the taxonomy do not link to the definition of CSA. So we added a top level to connect the enumerations and classes in the taxonomy to the levels of situational awareness And thus we have the perception with the data gathering, comprehension with analysis and visualization. And what was lacking in the original taxonomy was the projection level, where we added 4 tasks that are common in anticipatory CSA. Apart from that, we did a few changes, minor changes, such as moving or renaming some of the items between the categories. Finally, we identified challenges for research and development of CSA. We divided this into 2 perspectives, data perspective and toolset perspective. In the data perspective, we found out that the CSA exhibits characteristics in volume, velocity, veracity, variety, and volatility of the data, which makes the CSA data a big data. For example, we have to process network traffic or system logs, which are enormous in volume and velocity. Also, a variety of network traffic or types of attacks is increasing all the time, and we have to face new challenges related to this. When it comes to tools, we see many tools under development, but using the right tools is crucial for the operators to build and maintain CSA. And the question is how to make these tools reasonably. So let's start with data perspective. In the data perspective, we first tackled volume with velocity and veracity. The problem is that sensors produce massive amounts of raw data, but bring little understanding to what is going on. Briefly, data overload, meaning underload, which creates a demand for real-time analysis and real-time result delivery, which brings another problem because we are interested in the causality of events, which places an emphasis on correct timing and correct ordering of events, especially in cyber environment when 1 millisecond can make a huge difference. Second, we have variety and volatility, where the problem is that we have to homogenize data from different sources and of different times. Well, central processing is desired, but requires proper metrics and thresholds all around. Our problem is, typically, metrics and thresholds are set at particular sources of data. Also, attack behaviors are heterogeneous, network environments are heterogeneous, and we cannot depend on what has been observed in the past, because the past no longer applies in cybersecurity, and the threat landscape is changing all the time. When it comes to toolset perspective, we again start with variety, with veracity and volatility, because at the moment a special tool is needed to process the data from each different source, which creates a tension between specialized tools and unified tools. Also, we face problems with many competing standards and taxonomies, such as threat enumerations, threat taxonomies, and so on, between organizations and countries, either due to legal frameworks and so on. Finally, we have many tools for shared threat intelligence, which is vital, data flow fidelity. When it comes to visualization, we face problems with a high noise-to-signal ratio and low volume of information. And the task is to visualize large-scale, dynamically changing networks. An open problem or uncharted field is the anticipatory CSA that lacks visualization completely. Finally, performance issues are related to the data, so we need to ensure that the tools are scalable. And for example, the stream processing can help very much in reducing the delays and incident response times in case we are under attack. So that's all from me. So I'll just conclude my talk. First, we discussed the fundamentals of CSA and provided a brief overview of research, updated the taxonomy of CSA tools and components, and proposed the challenges for future work, when the most important ones are coping with rising volume, variety, and velocity of the data, supporting the CSA operators with the right data at the right time, visualizing the data in a meaningful manner, and maintaining sufficient performance. That is all from me. I'd like to thank you for your attention